All right, good evening, everyone, and thank you for joining us for the Energize East Hampton Green Heating and Cooling campaign webinar. We have a lot to cover tonight, so we're going to get started right away. Next slide, Gordian. So on this webinar, we are going to be introducing a brand new program added to the Energize East Hampton initiative, which provides opportunities for residents and businesses in East Hampton to heat and cool their homes or buildings more efficiently and even save money on the costs associated with heating and cooling. We'll go over the details about the campaign and how to sign up if you're interested in getting more information. And we'll hear from our installation partners selected by the town for this campaign, Green Team LI and Bestaire by Marios, who will give an introduction on the heating and cooling technologies and home weatherization services they will provide to the community through the campaign. After the presentations, we're going to have a question and answer session, and we will end with closing remarks. Next slide. So a few housekeeping items before we get into the presentations. During the question and answer session, we're going to start with questions that were submitted to us with registration, but there will also be the opportunity to submit questions during the webinar as well. Please submit your questions via the Q&A button on the bottom of your webinar window. You might have to hover your mouse over the window to get that toolbar to appear, but all questions submitted during the webinar will be answered publicly. We're not going to be answering any questions in that text box. We'll do our best to answer all questions tonight, and any that we can't answer, we will try and post on the Energize East Hampton website, energizeeh.org, with the answers. This webinar is also being recorded and will air live on LTV and be made available on video on demand at a later date. And we'll also be posting the webinar recording and the webinar slides on the events page of energizeeh.org. Next slide. So my name is Lauren Steinberg. I'm a senior environmental analyst with the town's Department of Natural Resources. My co-host on this webinar is Gordian Rocky, Executive Director of Renewable Energy Long Island and Energy Sustainability Consultant to the town. Next slide. So to get us into our webinar topic tonight, we should first talk about some background of the Energize East Hampton initiative. Energize East Hampton was started by the town of East Hampton in 2018. It's managed by the town's Department of Natural Resources and local nonprofit Renewable Energy Long Island. Energize serves the community by being a one-stop resource for energy and money-saving opportunities available to anyone who lives in the town or owns a business within the town or any of its incorporated villages. The initiative's website, energizeeh.org, has a great deal of information on how the town is working towards achieving its 100% renewable energy goals, including past accomplishments and our ongoing work. As well as resources for the community to become more energy efficient, explore renewable energy opportunities, and save money on energy costs. Visit the events page to watch past webinars on the Energize East Hampton programs and other topics like sustainable transportation or community choice aggregation. Energize consists of several programs available to East Hampton through partnerships with local organizations and industry professionals. These include free home energy assessments provided through the Long Island Green Homes program, which can help you identify ways to reduce energy waste and make your home more efficient. A Solarize campaign, which can make installing solar panels on your home or business easier and more affordable by taking advantage of discounts offered only through the Energize East Hampton program by a local installer, Green Logic Energy. The town selected Green Logic through a competitive pre-screening process to help the community take the guesswork out of selecting an installer. And now we're excited to introduce the newest program to the Energize initiative. Next slide. The Green Heating Cooling East Hampton campaign, like the other programs, Green Heating and Cooling is available to all residents and businesses in East Hampton. The goal of the campaign is to help the community learn about greener, cleaner heating and cooling technologies like air source and geothermal heat pumps, how to make your home and business more comfortable and energy efficient, and make installing heat pumps and weatherization improvements more affordable. The town issued a request for proposals for qualified installation partners to provide these offerings to the community, and a terrific team was selected who we're going to meet in just a few minutes. Next slide. And we encourage everyone to visit the Green Heating and Cooling Campaign page of the energizeeh.org website to see more of what the program offers, learn about the benefits of weatherization and heat pumps, and sign up to be contacted by our installation partners to find out what green heating and cooling options would be best for you. And we're going to go over this process again at the end of the webinar. So now I'm going to turn it over to my co-host, Gordian, who's going to talk about the importance of electrification in sectors like heating to reduce greenhouse gas emissions. Gordian?
Thank you, Lauren. So I wanted to just take a moment to give you sort of a bigger picture. Installing a green heating and cooling system in your home or in your business will save you money. It will make your place more comfortable. But it'll do a lot more than that. And that's why I just wanted to show you this slide here, which essentially shows how we're going to reduce carbon emissions, greenhouse gas emissions from where we are today to significantly less by 2030, and then ramping it down even further so that we essentially will be at a net zero carbon emission scenario by mid-century, by 2050. And what that means is that we have to, when it comes to heating, we have to make those heating sources not run on oil or natural gas, on fossil fuels anymore, but run them on electricity, which we can then generate with renewable energy sources. And so this is another reason why we started this initiative here in East Hampton. It's something that's being done statewide. By 2030, about 50 to 70% of all heating systems installed, new heating systems being sold, need to be heat pumps. So that would be right here. And this electrification of our energy use will also include, of course, electric vehicle, both light vehicles and heavy duty vehicles. But we're talking just about heating systems here for space heating and water heating, maybe pool heating. So those systems will have to switch over to heat pumps. And by 2050, we'll essentially need to be at a point where almost all of the sales of heating systems will consist of heat pumps. So this will allow the town of East Hampton, Long Island, the state of New York, to electrify the building sector, the heating sector, and the transportation sector, as I mentioned. And it will make sure that we keep climate change in check and that we avoid disastrous and irreversible damage from climate change. So with that, I'd like to introduce our two panelists here. The Green Team Long Island is an experienced and uniquely qualified one-stop provider of energy audits, of cold climate air source heat pump installations, and weatherization improvements. And their subcontractor, Bestaire by Marios, provides geothermal heat pump installations. These contractors will help residents identify and apply for rebates, for tax credits, and get low interest financing. Green Team Long Island is Long Island's largest PSEG Long Island home performance partner and has been named Home Performance with Energy Star Contractor of the Year for both 2020 and 2021 by the United States Department of Energy. So it is my pleasure to introduce Green Team CEO Jay Best, who will walk us through the presentation along with Marios Nicolaitis of Bestaire. Take it away, Jay.
All right, thank you, Gordian. Thank you, Lauren. So yes, I'm Jay Best. I'm the CEO of Green Team Long Island, and we focus on residential homes exclusively. So our job is going into primarily our existing housing stock and making it better and doing all the things that Gordian was just talking about, but really focused on homes. So We want to make the homes use as little as necessary, and then provide that with clean, efficient heat pump technology. And so we'll get more into both of those. We work, and the great thing in this industry is that there are a number of support mechanisms we have through New York State, through our utilities, and through various standards bodies. And you see a few of them on there. Home Performance Energy Star is an EPA and Department of Energy conduit that creates standards along with the Building Performance Institute. And then New York State oversees that. And so we were able to pull together programs that all of these offer, and really excited to work with the folks of East Hampton to make this happen, and very excited about this Energize East Hampton campaign that we're just getting started. Next. So the approach that we're going to take for most of this really isn't that much different than what we've been doing for a number of years. And that is, we start really with an energy audit, and we're looking to make homes use as little energy as possible. And that we've been doing that for a number of years, even before heat pumps were sort of, when they weren't as widely available and maybe didn't work as well in climates as they do now. And we'll get into some steps on that, but we're going to start off with energy audits and have different recommendations around that. And then providing really clean heat options. And we're very excited both about air source heat pump technology. And then we've started working recently with Marios, who has a terrific company doing focused on geothermal technology, ground source heat pumps. And so we'll get into all of that. And one thing to be kind of aware of is that because we're working with so many different organizations, there's really a lot of, there's a number of different people looking at what we're doing and making sure that both standards are obeyed, but that the homeowner can be confident in what's being provided. And so we see listed just a few of the different credentials that sort of come to play as a business that we're involved in. And, the idea is that you can have confidence that, both the work will be done well, and that we'll have, we'll be around to support it for a long time. Next. So the initial step is the assessment, sometimes called an energy audit. It's typically about 60 to 90 minutes. And we want to look at things that are really contributing to excess usage of energy in your home. And so we're going to look at air leakage, and we'll get into what that entails a little bit. If you have combustion appliances, a boiler or a furnace and a hot water heater are pretty typical. We're gonna test those out and make sure that there's operating safely. One of the tenets of building performance is that we want to do no harm, and so we want to make sure that even if this technology isn't right for you or isn't right for you right now, that at least the heating equipment you have is operating as safely and efficiently as possible. A lot of the work we're going to look at with the energy audit is going to look at the building shell, and that's basically that's the insulation, what's in the attic, what's in the walls, and making sure that that's adequate and that's performing well for you. We want to provide recommendations that are based on sound science, and very important with that. So that's all part of the assessment. Next. So there's a number of common issues that we're looking at there, and this is sort of a slide that was really generated by the EPA, and there's different areas of energy leakage in your home, and energy leakage is that causes your home to be drafty, to be cold, and it's literally money leaking out of your house. And so we want to stop those leaks up. And so the red arrows that you can see kind of in the top of the house there, these are things that's where air tends to leak out through different penetrations that are, part of the design of your home. And we want to seal those up the best we can. And then as air leaks out the top of your home, there's air that will leak in lower down. And so we'll be looking to seal up some of those things. So we're going to look at air leakage. We're going to look at insulation levels and make sure that that's appropriate. we're going to look at how you heat your home and how you cool your home, and provide you options that are going to be hopefully improvements. And then we will of course look at electrical load things, lighting, and appliances and occupant behavior. But a lot of those are things that you kind of already know. It's installing LEDs, it's buying Energy Star appliances, turning the lights off when you leave, unplugging cell phone chargers. So that stuff, you may not always do it, but we're really looking at ways that we can improve the physical structure of your home and the infrastructure within it. Next. So one of the things we'll do is an air leakage test or a blower door. When the weather's getting cold like this, we like to do it with an infrared camera, and the infrared camera helps us to show off areas where your home may be leaking. And it's it's actually code for most new buildings most new homes need to have a blower door test done as part of that getting a certificate of occupancy. Well, we bring that to existing buildings, and we want to see there's sort of an ideal amount of air leakage that is enough air that we get adequate exchange for for breathing purposes, but that we're not we're not leaking more than we need to. And even in cases where houses are very tight, it's preferable to have mechanical ventilation where we can run air through filters and things like that, rather than having air leaking in through through your basement or and out through the attic. Next slide. So I'm not going to spend a lot of time, because we've had other webinars where we've talked about how we fix houses, but we're going to look at things like air sealing. A lot of that's up in the attic with with caulking or sometimes a little bit of spray foam. And then on the right there, you see kind of before and after doing insulation. We really want to make sure that there's, the house is both tight and that there's a thick layer of insulation in the attic. And if possible, doing into the walls and into basements and crawl spaces and things like that. Air sealing and insulation will almost always be, some of the recommendations in order to make sure that a home is going to be as efficient as possible. Next. And then what we're very excited about, and really what this program is designed around, is clean electric heat with heat pumps. And there's two kind of fundamental types of heat pumps that we're going to talk about. The first is an air source heat pump, and air source heat pumps have been around for a while. What's new with air source heat pumps is that there are certifications now that make them, and manufacturers have designed them to actually much colder climates than we have on Long Island. So there's an organization called the Northeast Energy Partnership, or NEAP, and NEAP has created certifications and standards for air source heat pumps, and those are really designed to go below to zero. The standard is actually at 5 degrees. And almost all the heat pumps that we look at are designed to operate below 0 Fahrenheit temperatures. And that means that really they're going to work in colder climates than we have on Long Island. They're working in upstate New York, in New England areas. And so, they're able to work quite efficiently. And you may have seen heat pumps can come as ducted systems, which sort of look very much like traditional central air conditioning systems and how they're set up, or they could be ductless systems and mini splits, and we'll see a couple of pictures for those. And then Marios is going to get into a technology that's also been around for a while, but is maybe less, homeowners have viewed as less accessible, and that's a ground source heat pump. There's some really good reasons to think about using ground as a source of your heat, and Marios will get in a little bit of that. He's got a great video that kind of gets into that a little bit. And those can be ducted systems. There are some ductless options, and then also can be radiant floor. So it gets into a little bit, and it's hard to say what's right for any one person. That's really why we do the assessment, is to it's really looking at your overall home, your situation, and looking at, what are some different options for you so that you can make an educated decision about, how to green up your own home. Next slide. All right, so I talked a little bit about the cold climate heat pumps. Sometimes you'll hear them referred to as inverter. They can heat and cool quite cold, most of them rated down to about -15 degrees. They're both very efficient heating, and more and more as we see the effects of climate change, very efficient cooling. In a lot of places, you really need to have some kind of air conditioning in the summertime, whereas maybe you didn't need to have it in the past. And because these are run off of the grid, the intent here is that as we're able to green the grid, as we're able to add more renewables, really we're going to be heating and cooling our homes with renewable energy, whether that be offshore or solar or however it is. It's much easier to green the electricity that we use than say the fuel oil that we use or the natural gas that we use. So next slide.
There are many ways to heat and cool your home. Air source heat pumps move heat between the outside and inside of your home to keep your home a comfortable temperature all year round. Recent technology advancements in air source heat pumps now make them a strong alternative for space heating in colder regions like New York State. Ducted air source heat pumps are central systems that provide heating and cooling through your existing ductwork. Ductless heat pumps, also known as mini splits, are an example of an air source heat pump system that consists of two units, a slim outdoor condenser and an indoor air handler. Ducted and ductless air source heat pumps have several benefits over conventional HVAC systems. They're quiet to operate and highly efficient because they move heat rather than convert it. There's no combustion of fossil fuels, which leads to safer operations and cleaner air, and a lower carbon footprint. It also means that you can save money on your heating bill if your home is currently heated with fuel oil or propane. On top of that, what's unique about mini splits is that the indoor air handling unit is in the same room that is being heated or cooled. This indoor unit is connected to the outdoor condenser through a small opening in the wall or ceiling behind it. This means that mini splits don't require ductwork to carry warm or cold air throughout the home. No ductwork means that mini splits are very space-saving and flexible in where they can be placed, making them perfect for renovations and home additions. Are you interested in learning more about a ducted or ductless air source heat pump for your home? Here are some tips to keep in mind. Work with an HVAC contractor in your area to size the unit appropriately, and be sure to pick an air source heat pump system that is designed for a cold climate. For more information, visit the NYSERDA website.
All right. And then since we can now heat our homes with this clean, efficient heat pump technology, of course, there's a way to do sort of a similar thing for your water. And that's a high efficiency hybrid hot water heater. Hybrid hot water heaters are, essentially, they will use that same heat pump technology. They'll pull the heat from the surrounding area and use that to heat the hot water. And so they use a lot less energy than a standard electric tank. And the one you see there, essentially there's a tank underneath and kind of an almost refrigerator-like appliance that works on the top to pull heat from the surrounding area and put that into the hot water. And works great in almost all homes. Next.
We all want to save money heating and cooling our house or office, right? The answer may be under your feet, literally. Much of the heating and cooling can come from the ground, below the surface, with something called a geothermal heat pump. You see, below the frost line, about 10 feet down, the Earth maintains a nearly constant temperature of 54 degrees. We can tap into this energy to provide heating in the winter and cooling in the summer. Okay, now here's how it works. Bury a loop of pipes, called a heat exchanger, just below the surface, and fill them with water or a water and antifreeze solution. During the winter months, the air is usually cooler than the temperature below ground. The solution circulates in a loop underground and absorbs the Earth's heat. This heat is brought to the surface and transferred to a heat pump. The heat pump warms the air, and then your regular heating system warms the air some more to a comfortable temperature. Finally, ducts circulate the air to the various rooms. Now, a huge benefit is that the geothermal system doesn't have to work as hard to make people inside comfortably warm, and you save lots of money on your heating bill. In the summertime, the system works in reverse. When it's hot outside, the temperature below the surface is cooler than the summer heat. So the fluid in the loop absorbs heat in the building and sends it underground. The ground's lower temperature cools it, and it's circulated again and again. Now you're saving money on air conditioning. Now, this church uses a large geothermal heat pump to heat and cool the building. It has a very big parking lot, which lets it spread out its loop horizontally. But if you don't have all that space, you can go straight down and use a vertical loop system instead. Geothermal heat pumps can be used just about anywhere in the U.S. because all areas have nearly constant shallow ground temperatures, although systems in different locations will have varying degrees of efficiency and cost savings. The constant temperature of the Earth just below our feet is a sustainable resource, literally in our own backyard. It's a clean energy source ready for us to use to heat and cool our homes and buildings while lowering our utility bills.
And that's a great intro for Marios, who's going to take it away and talk more about ground source heat pumps or geothermal.
All right, good evening, everyone. I'm Marios Nicolaitis from Bestaire by Marios Inc. I'm a geothermal specialist on the east end of Long Island. And I'm excited to be part of the Energize East Hampton campaign. I could try to keep this very simple. Most of what the geothermal systems do are similar to the air source heat pumps, but they don't use the air for heat transfer. They use water through the form of what's called a ground loop that has to get installed in your house if you like to have geothermal. So the heat pumps, as the video said, they use solar energy that is stored in the earth from the sun. So it's applicable to any house anywhere in the world, or building for that matter. Next slide, please. So there are three basic pieces of equipment that are necessary in any geothermal installation. Number one is the ground loop. Number two is the flow center. That's a device that the water circulates to and from the ground into your house. And number three is the heat pump, which in most situations is ducted, although it does have the ability to work with certain ductless types of applications. Next slide, please. So the way that a geothermal heat pump will heat and cool your house is either through a duct system or ductless. It will also cool the house through the same ducts. And if you do have radiant heating or would like to include radiant heating in a new installation or a retrofit, you also have the ability to do so as well with geothermal energy. Next slide, please. One other benefit of geothermal is that you can also use the system to assist you in your hot water needs, which can cut costs of your hot water consumption in your house from anywhere from 20 to 40%, depending on how much hot water, how many bathrooms you have, and what your needs are in the house. It can also drive the entire hot water needs of your house as well, with a separate heat pump that's dedicated to that. Next slide, please. Furthermore, geothermal can also be used to heat your pool, or it could even be used to melt snow in your driveway. So the technology is not limited to just cooling the house, but there are many applications that can be used for geothermal. Next, please. So when we come out to look at your house, along with Jay and his team, we have to figure out what your ground loop field options are. So depending on the size of your property, whether it's a 40 by 100 lot or it's an acre to 5 acres or more, there are different options. So with that said, would you please advance to the next slide? The most common in our area on Long Island is what's called a vertical loop. That's where we have a drill rig that we drill down into the earth vertically. Depending on what the capacity needs are in your house, if it is a house that is 3 bedrooms, or if a house that's 10 bedrooms or more, the capacity will be determined on how many BTUs we need in the house. So the loop field will have to be sized to provide X amount of tons to heat and cool your house, just like a regular heat pump would, or a conventional system. So depending on how many tons we need in your house, that'll determine how deep we have to drill and how many loops we have to actually install into the ground. So the pipe itself lasts over 50 years, and it's a bit of a process. However, this is what we do. And the vertical closed loop installation holes will be anywhere from 4 to 6 inches in diameter. So the loop field is the heart of the system. And I think that the best way of determining how your house is able to support it is a site visit, and a survey would be necessary. So anyone that's interested, make sure that you can locate a survey of your property. And that would be one of the first steps in helping determine how we can support your property with geothermal. Next, please. The horizontal loop is the most common use when you have a lot of land area. So if you have a farm or you have 5-10 acres, that may possibly be an option. However, it's typically not the way the geothermal is installed. Next slide. If you happen to have a house that has an open loop system, that was pretty common back about 10, 15, 20 years ago. And open loop systems are great and they're very efficient when the water quality is very high. Fortunately, in our area, the water quality is not very good. Open loops are an option if you have good water quality only. If you have an open loop system existing in your house now, and you have any kind of an issue, we would be able to convert your system to a closed loop if you're having problems. Next slide, please. A pond loop is also a possibility if you happen to have a large body of water available anywhere near your home, approximately 200 feet from the home. It would have to be 10 to 12 feet deep. These are very, very rare on Long Island. However, there are some people who do have ponds on their property. If you're one of them, it might be a consideration for your home. Next slide, please. So Jay and I both were able to help assist with rebates, and federal tax credits are also a possibility. Everything that's here available to you could also be financed with $0 out of pocket.
Yeah, this there are programs from PSEG and NYSERDA is the state agency that's kind of helps with some of these things. There's also East Hampton has worked with us so that we're able to provide a discount on the services provided through this program, and of course on the federal end there's a 26% tax credit, which on the cost of the system depends some your ability to take advantage of it. Of course, depends on your personal tax situation. So we're not experts on that, but you'd want to talk to a tax professional you work with. the point is we're able to kind of pull these things together to give you, on your situation, to give you a comprehensive solution that, will take advantage of these different programs to make something affordable and work for you. And really, looking at the energy savings, as you use one of these systems, you're typically displacing your fossil fuel so that, you may have had an oil system in there, you might have had propane, you might have even had gas, natural gas. And in every case, you're going to be eliminating those fossil fuels. And the goal is to, have that be, a cash benefit to you. But even if it's not, 100% offset, you still get a number of benefits in terms of, a more comfortable home and new heating and cooling equipment. Next slide. So yeah, really the next steps are get yourself registered through the Energize East Hampton website. We would come out and do an energy audit that's also supported by PSEG in New York State. We put together a short report that includes those recommendations, and we'll sit back down with you to go over those recommendations. Based on what you found, we'll let you know based on your situation what kind of incentives and rebates. And there are the great thing on Long Island is almost everybody is eligible for some part of their work to be some incentive towards that, and that's whether you're multi-millionaire with lots of plenty of assets. There are programs that will help you, and if money's a little tighter and you're on a fixed budget, there are programs that can help you as well. So we able to put that together for you and give you a plan to move forward. Next.
All right, I think we are at the end of this great presentation. Thank you both for a very informative presentation. So for the audience, if you like what you heard, if you want to find out more about it, as Jay said, you go to the Energize East Hampton website, energizeeh.org. You simply select the program you're interested in from the program bars at the top. In this case, that would be green heating and cooling, and you find some more information. You can read through at the bottom of the program page. You'll find a link to our Tell Me More form, which you see here, and you simply check the boxes and say, yes, I'm interested in heating and cooling with heat pumps, for example. Then it'll ask you a little bit about what your current heating system is, what your air conditioning, if you have air conditioning, and what that is, and how old your building, your home may be. And then you can check other things too. If you're also interested in solar, you can check the box here on our Solarize program, et cetera, et cetera. You might want to be adding energy storage to an existing solar array or newly installed one, and so forth. So this is a great one-stop shopping place where we have tried to put everything in one place, and you can check those boxes and then put your contact information in and hit submit, and it will go to the program providers, to Green Team Long Island in this case, if you're interested in green heating and cooling, or any of our other program providers. They will get back to you and take it from there. So with that, I think I'll turn it back over to Lauren for our Q&A.
Thanks, Gordian. So now we're going to move into the Q&A portion of the webinar. Again, if you'd like to submit a question, we've had a couple really good ones rolling in. Please do so through the Q&A button in the toolbar at the bottom of the webinar window, and we'll get to as many questions as time allows tonight. So First one we got in, it's a great question. I think we touched a little bit about it in the presentation, but always good to revisit. And this would be good, I guess, for both of our contractors. And it's, can you provide some data that will help me choose whether an air source heat pump and between an air source heat pump and a geothermal unit? From my research, both of these systems can be very effective and provide great cost savings, but how do they perform when winter temps get below freezing? And how do these systems compare to each other and to oil-based systems given normal East Hampton temperatures?
Sure. So I'll take a stab and then Marios jump in when you get to it. So yeah, both of these systems can work well on Long Island temperatures. You know, typically we're designing for what we call the design temperature, and what that means is sort of the coldest typical winter nights. Long Island is not, you know, it's not super cold. It's, you know, maybe our design temperature, depending on, you know, where you are, somewhere between you know, 15 to maybe 17 or 18 degrees. And that's not, you know, that's not that cold compared to, you know, just a little bit further north from here where you get into, you know, central New York. It's, you know, much closer to zero. You get up into New England, it drops below zero. So we're in an area where, you know, this equipment can work really well. And now when it does get cold, the air source heat pump will drop off a little bit in the efficiency level. And so depending on the type of systems, we will incorporate, sometimes particularly for ducted systems, we will incorporate sometime a backup auxiliary heat, you know, that can be included in that. And really that's some kind of electric resistance, so that, you know, on those times where, you know, if it was very cold and the system couldn't quite keep up, it gives a little extra boost to the to that system, so that, you know, the house is able to stay comfortable. But they will continue to put out, you know, the heat pump part of it will continue to put out heat to a quite cold temperature. The advantage that the ground source heat pump has in that situation is that the ground, as the video was talking about, stays a relatively constant temperature. And so that ground source, so even on the coldest days of the year, that system might need to provide more heat because it's colder outside, and even a well-insulated building is going to lose more heat. But it's pulling from you know, a 54-degree ground, as opposed to, you know, maybe it's in the, you know, the low teens outside that the air source heat pump. So so the ground source definitely, you know, has some advantage there in, you know, the coldest months of the year. And similarly, it'll have an advantage in the hottest days of the year, so that, you know, when it's 95 or more outside, and it's pulling heat from your house in air conditioning mode and dumping it outside, that air source heat pump's going to have to work a little bit harder than the ground source heat pump. That, you know, again, what is it doing? It's pulling, you know, heat from your home and dropping it into, you know, a 50 or 60 degree ground, and that's going to be, you know, sort of easier for that system to work. So it's going to tend to have you know, lower peaks and valleys. It's going to be able to operate a little bit more steady through all environments.
Yeah, so both systems are very, very efficient, and even in the air source heat pumps, you know, the times that we have 15 degrees or between 0 to 15 degrees, it's not for the entire season. So both systems will still perform. The geothermal heat pump has the advantage of a constant ground temperature. So rather than the air source heat pumps are depending on the outdoor air temperature, provide that heat in the house, and the geothermal systems are depending on the ground temperature, which is more constant. So the key thing about either system to be efficient in your house is, number one, to make sure that the insulation and everything that Jay has to offer, that's the first step. So each system is going to be only as efficient as your house is, airtight and insulated. That's something that's very important, I think, to take into consideration. The ground source heat pumps, as far as efficiency levels go, you know, they are able to achieve a higher efficiency, and they're going to provide as much or as little heat that you need in your house continuously. And that goes back to the loop field. So when we size the loop field, that is what's called your heat exchanger in your house. So depending on the size of the loop field, that's how much heat or cooling you're going to be able to bring into your house. So we typically size those loop fields to be able to provide all the heat that you need, no matter how cold it is outside. And in the event that the system needs additional heat, or we have some kind of abnormal temperatures that typically we don't experience in our area, as Jay does in his systems, in the air source heat pumps, you would incorporate some kind of emergency heat in part of the system, which is done through an electric strip resistance heating unit. So it's not necessary, but it's there in case of emergencies.
Great. Okay. Next question we got in is, my old house had an open loop geothermal system that used county water. A well was not an option. Summer water bills were over $7,000. My electric bills for running the geothermal were also very high. I'm building a new house soon. Why should I reconsider geothermal?
Wow. First of all, I'm not quite sure why the house was running on public water.
Yeah, I think that's a legal system. That's not a legal system now, right?
No, it's not allowed. I mean, there have been situations where people had open loop and they had a catastrophic failure in the well. And you can't get somebody just to come, you know, the way that you'd have someone come to your house for a service call and repair something. That requires perhaps drilling a new well or replacing a pump. That it's not a quick fix. So with that said, I suspect that at some point in time, someone gave a temporary solution to this house to get the system working, because geothermal does use water. That's what it needs in order to operate. And it was left that way for quite some time, and perhaps that I'm not sure if you had someone do that or you inherited the house with the system functioning that way. It can be converted to a closed loop system, and that's the best way to approach a system that has that issue. It would not cost anywhere. It wouldn't cost you anything as far as water goes. A closed loop system it's a series of pipes that are filled with water one time, and antifreeze solution, and it recirculates the same water over and over again. So you would never have to spend $7,000 on water. As for the electricity, it's possible that the system could be undersized in the house. It wasn't able to provide enough heating and cooling without some kind of additional backup heat. Maybe that was in the form of electric that was running continuously. It's tough to say. I'm sorry that you had that situation, but for today's system and the way that we design installed equipment now would not use public water, and it would not depend on an additional form of heat, again, unless there was some kind of failure or an emergency situation. So geothermal, the technology today, between how efficient it is and the potential tax credits and rebates that are offered, just to give you an example, if it was $100,000 to install a brand new system in your new house, that would compute to a $26,000 tax credit if you qualify for it. And the rebates on that house could be anywhere from $20,000 to up to $30,000 potentially, depending on how much heating and cooling the house needs. So right there, it could potentially cut that cost in half if you factor those rebates in. And if you compare it to a conventional system where you have to burn fossil fuel, you would most likely need to have a boiler, plumbing, a piping system, and air conditioning units. So sometimes it turns out to be a wash if you're going to build a new house. If you consider geothermal, it may be an option again for you, but you have to have the right people to come in, and you have to have the proper assessment done and design for the system to be incorporated into your house.
All right, great. So the next question we've got, we got a lot, which is great. What kind of backup would be best with a heat pump in the event of a power grid outage? Would battery storage be enough to sustain several cloudy days? And I'm presuming this is referring to a battery storage system linked with a solar PV system on a home.
So, no, the short answer is probably not. A battery storage, still only provides really enough energy for, a few lights, a refrigerator, maybe some internet connection, but it's not going to provide enough for heating and cooling of your home for either type of system. There are whole house generators that people will look at sort of in that sort of catastrophic failure. But I'll remind you that boilers and furnaces don't work without power either. So you're going to probably need, if heating and cooling is part of your objective, it's likely that battery storage is not going to be enough in its current form, unfortunately.
Okay. Would a heat pump be a good option for a home with solar panels?
Heat pump's a great option for houses with solar panels. The thing to remember is that, it's sort of a natural that as you're, if you can generate your own electricity, you can generate your own heating and cooling, right? But do keep in mind that depending on if you have an existing system, depending on how it was sized, these systems are going to probably cause your the total amount of electricity that you're using to increase. So you may find that if you are running close to 100% now, you may use a little bit more than what you were generating before. So you may want to upsize that system, or if you're designing a new one, design it with a heat pump in mind so that you have that extra capacity.
Okay, great. This question is for you, Jay. Does Green Team also consult on new builds?
So this is something we do consult on some new builds, but I'll be honest, our forte is really the existing housing stock. There's a lot of great architects and companies that have built their business around the tremendous housing market that's out there in East Hampton, and new construction. But our forte and focus is really on existing houses and fixing what's broken.
Okay.
I can add to that as far as consulting on new builds. If it's HVAC related, with sizing the house, that type of service, that's something that we can help provide. But if it has to do with modeling the house, insulating the house, all those things, that's something that's typically would be done through the architect that's hired and HERS rater that they would have to hire in order to obtain a permit. That can be done through those channels as well.
Okay. Why are rebates for air source heat pumps so little on Long Island compared to the rest of New York?
Oh, I love that question. They're really, other parts of New York State do have some higher rebates. If you asked me that question maybe 18 months ago, 2 years ago, I would have said, oh, no, PSEG had the best rebates in New York State. And we've kind of been leapfrogged by other parts of the state. I hope that PSEG in the future is able to increase them. There's a long sordid history about, why our utility is the way it is. And so, but the upshot is that the funding for these programs comes from different sources on Long Island than it does in the rest of the state. And so, we just don't get it quite as good at the moment, maybe at some point in the future, the incentives, but they can be quite good. And we see incentives for air source heat pumps that, will be in, 5 to 5,000 for some of our lower income homeowners. We've had, $15 or more $1,000 in air source heat pump rebates. And then you couple that with low cost financing that New York State does provide on Long Island, as well as the rest of the state. And it really becomes a no-brainer. You're getting rid of your oil or propane costs, and you're getting, adding a little bit back for electric, but it turns out that, it's really paying for itself in not very long period of time.
Okay. Next question is, with only one vendor, how do we gauge whether the pricing of these providers is competitive? I would like to just jump in really quickly first to say that when we went out to RFP for this program, and we being the town, we received proposals from several different contractors, several different teams, and we did that so that we can provide through this campaign a team that is qualified and pre-vetted by the town, and it takes some of the legwork out of choosing a contractor, which can be overwhelming for different projects. And one of the pillars of these sorts of campaigns, whether it's this one or a Solarize campaign, you are free to shop around. You're free to shop around to different contractors and get different quotes. What's important to us is that we are transitioning our heating away from fossil fuels and to these electric heat pumps. And you can do that however you like.
Yeah, and these rebates, we have a good handle on them, but there are other great companies that, that will be able to provide these rebates as well. And so, you shouldn't, we think we have a great team, but if, you don't think it makes sense, by all means, talk to other people. I will say, having been on, we've been involved with other programs, and, we haven't always been the preferred contractor with towns, but having a program like this just elevates the work, in the sense that people become aware of it. And, even when we weren't a preferred contractor, we found that people were interested in this type of work. And, so there is some spillover effect, but we think we have a great team. We don't think cost is the only thing there. You really want to have confidence in the team and know that, you're going to get good work. And I think we've put together a great team here with working with Marius.
Well said, Jay.
Likewise.
Yeah, sorry, Marius, I didn't mean to interrupt, but
No,
I
that's okay.
noticed that we are actually, at the end of our time here. That went by really fast. There was a lot of really great questions. So I just wanted to wrap up really quickly and let you know if we didn't get to your question. Like I said, we're going to try and put together a Q&A sheet with the answers to those questions that we'll post on energizeeh.org. And you can always reach out to contact us on energizeeh.org if you think of a question later on, and we can connect you with our contractors to get the answer. So we hope that you enjoyed hearing about the Green Heating and Cooling campaign tonight and its piqued your interest in exploring greener and cleaner heating and cooling options for your home or business. Again, please visit the energizeeh.org website for more information and to sign up to get started. Again, we're going to post the recording to this webinar on energizeeh.org along with the slides so you can rewatch or share. And please follow Energize on social media for announcements on future webinars, updates to our programs, and much more. I want to thank so much our installation partners, Green Team LI and Bestaire. Those are great presentations. We hope you enjoyed. Thank you all so much. Have a great night.
Thank you.
Thank you. Thank you very much. Have a great evening.